All right, so let's take a look at section 3.4, and it's called solution by matrices. I think we mentioned, did I mention this in brief yesterday? The plural is matrices. What's the singular? Yeah, so the singular is matrix. I watched this one guy's video, Khan Academy. You know Khan Academy? And the first thing he had on his paper was like a picture of the poster of the movie, The Matrix, and he talked about it a little bit. To tell you the truth, I didn't really know where you could use this stuff, but after watching the videos that I've been watching on this, apparently in computer programming, like real computer program, not IT kind of stuff, but things where you're actually writing code for things, even like for games. You know, I've had students leave here and say, I want to be a video game maker or whatever you call it, engineer or whatever. I want to make video games. Well, you got to know a lot of math, and apparently to write the code and stuff, this is very helpful, doing matrices. All right, so that's the one thing that I learned by watching all these videos, that people actually use this stuff. They use it because if you can set up one matrix, I don't know all this stuff, but I'm just going by what I heard. If you set up one matrix, the computer can like copy that. You've heard algorithm, right? All that kind of stuff. Well, algorithm is really a math word. People say algorithm just to mean like if you look at this video, then another one pops up like it. You know, that's everybody talks about the algorithm all the time. But it used to be only math people would ever use the word algorithm. Now everybody uses it all the time. All right, so that's what they try to do in here. You set up an algorithm, then the computer can copy it and just run off all these things and do it so much faster than anybody else could. So that doesn't really explain why you use this, but people do use it. So there you go. So, and the plural of, so that you have one matrix and you have multiple what? Matrices. So it's not two R's, matrices. There we go. All right, so it says solution by matrices. That's just the plural of matrix. All right, and a matrix just basically is just, they call it a rectangular array of numbers. So it's just a whole bunch of numbers in a rectangle, okay, and then you do stuff with those numbers. That's about the most simple thing I could think of with this. So let's look at some examples of matrices. A matrix, you usually use a capital letter to represent a matrix. You can use an equal sign, and here's a key to a matrix. Use this little bracket thing, all right? So all your numbers are inside a bracket. So again, it's just a rectangular array of numbers. So I'm just going to use the numbers. Nothing special about these numbers. 1, 2, 3, 4, 5, 6. This would be a matrix, all right? And you can do some stuff with it. You can add matrices. You can multiply them. You can you can add, you can subtract, you can multiply, you can divide. You do a bunch of stuff with these, and there's different methods, okay? To add matrices is pretty easy. We're not even going to do that right now. We're going to do something more specific than just talk about matrices. Anyway, so that's a matrix. So there's a couple things about the matrix that you need to know that we're going to refer to quite a bit. See this group of numbers right here and this group of numbers right here? Those are called the rows of the matrix. So those are the rows. That's a row, that's a row. Everybody got that? Yep. And then this one, and this one, and this one, these are all called, what do you think? Columns. I watched, it was Khan Academy. Khan's a super smart guy. Way smarter than I would ever be. I'd ever hope to be. But he spelled columns incorrectly. He didn't put the N on there. And I was like, oh. I looked at all the comments on the video just to see if anybody would say anything about it. I didn't see anybody say it, but anyway, there's an N right there. So these are the columns. So how many rows does this particular matrix have? How many rows? 2. Right. They go across, okay? So this is one row, this top row, then a bottom row. How many columns does this thing have? This has 3 going up and down. So there's one column, there's a second, there's a third. So we call this a 2 by 3 matrix. So you always number it by rows and columns. So it's always rows and then columns, rows by columns. Everybody understand that? So if I talk about a 4 by 3 matrix, what does that mean? There's 4 rows and 3 columns. Talk about a 3 by 4 matrix, that's different. That's 3 rows and 4 columns, okay? So it doesn't go in alphabetical order, but it's RC. RC Cola. Does anybody drink RC Cola? It's still in the grocery stores. Used to be a lot more popular back in the day. We used to actually buy RC Colas from the gas station, and they would be in glass bottles, and the bottles would be in a little wooden crate that were separated, so each little spot had a place for a bottle of RC Cola. And so anyway, when I think of RC, I think of RC Cola. We used to drink them. And then, this is back in the olden days, and then after you drink it, you put the glass bottles back in the little container, the wooden separator thingy. Well, I don't know what you call it. And then we would take it back to the gas station, and then they give you money for it to return the bottles. They don't do that anymore. So, man, I've lost everybody. I might as well. I'm going to talk to you, okay? Is that all right? So you're not the only one listening, but anyway. Yes, I do have a few people listening. Most of you are out, though, but that's okay. It's up to you. Let's do this. Let's do another one, and I will just ask you, what are the dimensions of this particular one? So this is going to go 1, 3, 5, and this is going to go 2, 4, 6. All right, right there, it's a matrix. So what are the dimensions of this matrix? It's a what by what? How many by how many? 3 by 2, very good, because you got 3 what? What are these? 3 rows, right? So it's 3, and then you've got 2 columns, so it's a 3 by 2. So that's kind of important. One more. That's how you measure what? Boards? Yeah, exactly. So let's do another matrix just so that we're all on the right page, and when I talk about a 3 by 2, you know what I'm talking about, and so on. That's 12, that's 14, 16, 18. All right, there we go. We're not really doing anything with this. We're just describing it, basically. So what are the dimensions of this one right here? 3 by 3. That's an easy one. When they're square like this, right, it's pretty easy because they're same rows, same columns, so you can't get them mixed up. By the way, since I said square, we actually do call this a square. Let's make my cue look a little bit better. We call this a square matrix. Okay? So when it's the same number of rows and columns, we call it a square matrix. So you could have a 2 by 2, a 3 by 3, a 4 by 4, whatever. Okay, that would be a square matrix. Everybody good with that? All right, that's enough preparation. Let's actually do one now. So what we're going to do, we are going to set up a matrix, but before we do that, what have we just finished doing in the last 2 lessons? We've done a system, what do we call it? Systems of what? Equations, right. And the first one we did, we just had, how many variables did we have? Just 2. We had an x and a y. The first time we did it, we just had an x and a y, right? And then we proceeded up to a what? 3, x, y, and z, all right? We won't do the x, y, and z today. We're just going to do the x and y today, all right? So here we go. This really, they start you off in the book. If you looked at the book, example 1, they start off with a x, y, and a z, all right? So 3 variables. I decided to work our way up to it, just to make it a little bit easier, all right? So these are, actually we're going to do a couple problems, maybe 1 or 2, let me see. Yeah, 2 problems that are actually on the homework that I'm going to give you to do. So, and my homework might be a little bit different than what the lesson plan, so the lesson plan kind of went out the window because I changed things up a little bit. So what we're going to do is this. We are going to take a system of equations, and I'm going to show you how to take this and turn it into a matrix. And supposedly, I think if you got used to it, I think it would be easier. I really do. I think it would be easier to solve this using matrices. At first, when you're first learning, you're like, oh, why do we got to learn this? It seems so much harder than just solving for x and y right now. Like I could do substitution. I could get x by itself, plug it back in, and boom, in a few steps, I'd be done. Or I could do elimination, right? I could do this by elimination. Well, what we're going to do is we're going to use matrices, or a matrix, one matrix, and we're going to use it to solve for x and y. And it's actually kind of cool. It's kind of interesting. First thing we're going to do is this. We're going to set it up as a matrix. How do I write that like this. I don't have any x's and y's here, okay? So where do they all go? Well, the nice thing about this, it's kind of streamlined and the x's and y's kind of go away. All right, so it makes it a little bit easier so you don't have it's not so cumbersome. There's not so much stuff, all right? It's just numbers we're going to deal with. So what we're going to do is we're going to take the coefficients and we're just going to write down the coefficients. We're not going to write the x, we're not going to write the y or the equal sign, okay? We're just going to write the numbers. So what we're going to do is we're going to take that one, and that one, and just write those numbers next to each other. I'd leave a little bit of space in between. I don't put it like right next to each other. I'm not going to make it look like a 235. So I'm going to write it with a 2, a little space, a 3, a little space, and then a 5. So far, that's pretty easy, isn't it? Everybody see that? Okay. And so what do you think you're going to do with the second row? What do you think the first number is going to be? A 1. Good. Because that's a 1 right there. It's a 1x. What's the next number going to be? A 2 and then 3. Good. Right? We probably should, but I'm going to get rid of those brackets after a while because they just sometimes they just get in the way. All right? And I'm just going to leave them off. Some books do this. I don't think this book does, but a lot of people on the videos, and I remember when I did these things, when I used to do this, we would put a line right there. There's nothing really special about that line. You don't really have to have it there. But what it does, it just kind of separates what our x and y's are from our answer, right? From whatever it's equal to, right? It just looks a little nicer, okay? So now, here's what we're going to do. We have a goal. Our goal is to do some things with this and to make it look like this. We want a 1 to be on top. We want a 0 to be here. We want a 0 to be here. We want a 1 to be here. And then this is just going to be a number. I'll just call it x and y. All right, so whatever the numbers come out to be, that's what the number is going to be. Okay, it's not going to actually be an x. It's just going to be a number. All right, I could put a and b. I could put p and q. Whatever. Okay, I chose x and y. But here's what we want to do. We want to arrange this so it looks like this. And what's going to happen is going to be really nice because what is this then? This is what letter? X. And this is 0y. So this is x equals whatever that number is. So if I could get this to look like this, I could look at it and just say, oh, x is equal to that number. And then what is this one? That's a y is equal to that number, right? And then our answer just it almost like just appears, almost. We got to do some work to get it to appear, but that's what we're trying to do. We're trying to get it to look like this. How in the world are we going to do that? Well, first of all, look, I got a 2 up here and I got a 1 down here. So let's do this just to make it a little bit easier for us. Let's just switch the rows because we can do that. Because like over here, did it matter that the 2x plus 3y equals 5 was on top? Nah, it could have been on the bottom. It wouldn't make any difference, would it? So let's just, since this is a 1 already, let's just switch rows and put it on top. Everybody with me on that? Okay, so because remember, this is our goal. We want it to look like this. So wait, I want a 1 up in the top left. I got a 1 here, so let's just write it 1, 2, 3. And then we're just going to put a 2, a 3, and a 5 down here. Okay? I'm going to quit putting the little brackets there just because it gets in the way. All right? And it just becomes a little bit obtrusive. So here's what I want to do. Just like we did here. Remember when we solved these by elimination? What would I have done to that x? I would have what? Multiplied it by, well, not a 2, but a -2, then added them up. Everybody see that? We're kind of going to do the same thing here. So what I'm going to do, let's use a little different colors here. What I'm going to do is multiply this by a -2, and then I'm going to add it to this. Kind of like what we would have done up here with elimination. Okay? That's it. You're going to multiply everything by -2. All right, so I'm going to multiply that one by -2, this one, this one. So we're kind of doing 2 steps in one. And then what I do, I put a little double arrow. I guess you could put an equals, but anyway, I put a little double arrow to say that this is equal to this, all right? So let's do the math. So watch what we're going to do. We're going to go negative 2 times 1. Let me just double check, make sure I'm doing this, because this is new for me too. This is pretty new for me. And then we're going to add it. Yep. So watch this. I'm going to go negative 2 times 1, which is what? What's negative 2 times 1? It's negative 2. Then I'm going to add it to this 2. What's negative 2 plus 2? It's 0. So what I'm going to do is I'm going to replace this bottom row. I'm going to take this and I'm going to replace that bottom row with the top number times 2, and then I'm going to add it. All right? So watch what I'm going to do. Negative 2 times 1 is negative 2. Plus 2 is what? 0. So the bottom row, instead of a 2, I'm going to put a 0. I watched one guy, he was using a whiteboard. He would just erase this and stick the 0 right there. All right, but I don't want to do that. Now we do the same thing here. I go negative 2 times 2, which is what? Negative 4. What's negative 4 plus 3? It's negative 1, and I'm going to put that negative 1 right there. Okay? Now, why did I do that, by the way? Because I already got the 1 on the top left. What do I want down here? I wanted this to be a 0. That's the whole reason why I did this. Okay? Because if I took this negative 2 times 1 is negative 2 plus 2 is 0, that's what I want. Okay? That's why I wanted the 0 right there. Let's do this one. 3 times negative 2 is? Negative 6 plus 5 is? Negative 1. It's negative 1. So I put a negative 1 right there. Now the top row, I'm just going to leave the way it was. Okay? If you want to put that little bar there, you can. It doesn't really make any difference. So I'm getting close. I got the 1 at the top left. I got the 0 on the bottom left. So I got 2 more things I got to change. What do you think the easiest thing right now is to do? Again, I want it to look like this. I want a 1, 0, 0, 1. I want 1, 0, 0, 1. Yeah, I would do that. I would make this negative 1. I would make it into a positive 1. So how do I make that into a positive 1? Just multiply it by a negative, right, or a negative 1. So what I can do is just multiply the bottom row by negative 1, then I'll automatically change that to a positive 1. I should take a picture of my class. This is how exciting my class is. Got half the heads are down on the desks. Doesn't say much for my teaching, I guess. So what we're going to do is we are going to multiply this by negative 1, this by negative 1, and this by negative 1. And let's see what we get. So I'm not adding it to anything because I don't need to, because just multiplying it by a negative 1 will change that to a positive 1. So I'm going to keep the top the same. Oops, spread it out a little bit. And then the bottom, what's negative 1 times 0? It's just 0. Negative 1 times negative 1? It's positive 1. Negative 1 times negative 1 right here? Positive 1. So I'm getting close, aren't I? I only got to do one more thing. I got to change this 2 into a what? To a 0. So I'm going to do kind of what we did over here. All right? So what I'm going to do, I'm going to keep that 1 there. What I'm going to do, let's make that red. I'm going to multiply this bottom row by what? What do I want this to be so when I add them up I get a 0? A negative 2. So I'm going to multiply that by negative 2, by negative 2, by negative 2. Okay? And then what I'm going to do, once I multiply those, then I'm going to add it to the top. So the bottom's going to stay the same. When I add it to the top, that's the thing that's going to change. And then we'll be done, actually. Okay? So let's do it. What's negative 2 times 0? 0. Plus 1 is 1. All right? So that didn't really have to change, did it? That stayed a 1. So that stays a 1. By the way, the bottom stays the same. I'm just going to write the bottom like that. Okay? So what do I do to this? I go negative 2 times 0, which is 0. Plus 1 is 1. Let's do this one. Negative 2 times 1 is negative 2. What's negative 2 plus 2? 0. And so I replace that 2 with a 0. All right? because I'm adding the negative 2 to it. And then over here, 1 times negative 2 is negative 2, and I add it to 3. What do I get when I add it to 3? Negative 2 plus 3. If you can't... Who is it? Oh, okay. Yeah. I got to wake him up first. All right, so what's negative 2 plus 3? That's 1. So I replace that 3 with a what? With a 1. Now, check this out. Now I'm done doing all my work. So I can put the brackets back on. I mean, technically I should have had the brackets on all through here, but it's just a pain in the butt, so I don't do it. Now, do you remember what our answer is then? Look, now I know what x is equal to and what y is equal to. So what's x equal to? It's 1. And what's y equal to? It's 1. That's right. See, this is 1 what? X. This is 1 y, and that's what they're equal to. So x is 1, y is 1. We still write it as an ordered pair, so what's my answer going to be? 1, 1. So that is how we're going to write the answer. After a while, once you start getting used to this, you start getting into that little routine, right? And then you're looking at it, you're like, okay, I just want to get that to be a 1, that to be a 1. I want that to be a 0, that to be a 0. What am I going to have to do with this stuff in order to make them 1s and 0s? Once I do that, and you start getting the swing of things, it could possibly be easier than doing it with the x's and the y's. All right? I don't know. I'm still debating whether it's a better way to do it or not. It's definitely a different way to do it, but you can still get the same answer. We're not going to do this, but if you wanted to, you could go through this process right here, do substitution or do elimination, and then see if it is the same answer. It will be, okay? It'll be the same answer. Or just plug them in and see if it works. It's a good idea. Let's just do that. So x is 1, correct? And y is 1. So 2 times 1 is 2. 3 times 1 is 3. 2 plus 3 is 5. Yep, that works. Let's put a 1 in for both of these. 1 times x is 1. 2 times 1 is 1. 1 plus 2 is 3. Yep, it does work, doesn't it? So it absolutely works. Question? I can't. You got to speak up. I can't hear. Like right here? Like this one? This one. Okay. So what I did is I multiplied everything by negative 2. How did I know to do that? Because I want to keep the 1 where it is, because that's good, right? Because it's already where it's supposed to be. So I need to turn this, well, I need to turn this 2 into a 0. That's what I'm trying to do. I'm trying to turn that 2 into a 0. How can I do that? It's like up here. Like if I multiply that by a negative 2 and I add those up, the x's would cancel out. Do you see that? And that's kind of like here. It would be a 0x. So what I'm going to do is I multiply that by negative 2, which is negative 2, and then I'm going to add negative 2 to 2. So I didn't really show that step, but we kind of talked through the step, okay? Again, I looked at a lot of videos to see what they're writing down. Most people that show how to do these problems just do this in their head. They don't even put the negative 2 there. They just say, well, negative 2 times 1 is negative 2, plus 2 is 0. Boom, they put a 0 down there. All right, but at least we wrote this part of it. So negative 2 times 1 is negative 2. See that little arrow right there? That means we're going to add what we get for that to this. And then we're going to replace that 2 with what we get when we add them up. All right, that's a big part of doing these matrices, okay? So what's negative 2 times 1? It's negative 2. Negative 2 plus 2 is what? 0. So I replace that 2 with a what? A 0, which I did right here. See that? Then right here, this step right here was kind of easy because we didn't have to add it to anything. All I saw was this. I was like, oh, this is a negative 1. Well, it's really close to a 1, isn't it? Mm-hmm. But how do I get rid of that negative? Well, I just multiply everything on that bottom by a negative 1. And that's how I got this right here. So I went 0, negative 1 to 0, 1, 1. Then I said, okay, I'm almost there. I got my 1, I got my 0, I got my 1. Now all I got to do is change that to a 0. How did I do that? Well, I took that 1 and multiplied by negative 2, because when I add negative 2 and 2 together, I replaced this, and I got a 0 out of it. Okay? Right here, I went negative 2 times 1 is negative 2 plus 3, right there. Negative 2 plus 3 is what? 1. So I replaced that with a 1. Okay? I did it here too. Negative 2 times 0 is 0. 0 plus 1 is 1. I didn't have to replace it because it's still a 1. Does that make sense? That's why I got 1, 0, 1 right here. Then once you get to this, let's get rid of the x and the y. Once you get to this, that's your answer, basically. All right? You just have to be able to understand what it means. It just means x equals 1. This means y equals 1. Okay? So it's kind of a slick little way to do things. All right? You don't have to worry about putting x's and y's in there all the time. Okay, that's kind of nice, all right, where you're just dealing with numbers. But at first, yeah, it's going to get a little bit weird. There? Yeah, for when you just have x and y, our goal is going to have 1, 0, 0, 1, all right? Because why? Why do we want that as our goal? Because this is 1x, so x equals that right there. This isn't always going to be 1, 1 right here, okay? It just happened to be a 1 and a 1 when everything else is 1s, okay? And then this is what? A y. This is 0x plus 1y, so y equals what? It equals that number right there. Let's do another one, okay? When are we out of here? 45? Okay. Let's do another one. Now you get the basic idea. So let's do one just a little bit faster, not much. This is actually one of your homework problems. So you might want to write it down. This is number 21. I will assign number 21, so I'm going to do it for you right now. So here's what it tells you to do. It tells you to solve, and then it gives you this system of equation. X plus 2y equals 4, negative 4, sorry. And then 2x plus y equals 1. All right, there we go. But we want to do it by matrices. They give this a name. I'm not going to worry about the name right now. Let's just solve this using the matrix, okay? So first thing we do is we write down the coefficients. That's a 1 in front of the x. That's a 1 in front of the y. So let's write down the coefficients. What is it? It's 1, 2, negative 4. What's this one? 2, 1, 1. Again, what's our goal? Is to write 1, 0, 0, 1. This is what we're trying to do. Okay? Well, we already have a 1 up here, and we got a 1 down there. Wow. That made it pretty easy, didn't it? This is the first problem that they give you, so you know it's going to be a little bit easy. All right? So that was nice. So really, all we got to do is make this 2 into a what? Into a 0. So how do I make that 2 into a 0? I take the top and multiply it by negative 2, and then I multiply this by a negative 2, and I multiply this by a negative 2. Make sure you got to do that to everything up there. And then I'm going to take that, add it to this, and replace that number with what they add up to be. You follow me on that? All right, so let's go back to white. All right, so let's do it. So I'm going to replace this one, so the top row stays the same. So I don't have to mess with the top row. But I do have to multiply it, though. Negative 2 times 1 is negative 2, plus 2 is what? 0, right? Negative 2 times 2 plus 1 is what? Negative 3. It's negative 4 plus 1. If you can't do that in your head, write it off to the side. Negative 4 plus 1. Now you see it, don't you? Okay? And then what's this going to be? This is negative 4 times negative 2, which is 8. And then what? Plus 1, which is 9. So actually, we made it worse, didn't we? Because that was already a 1. Now it's not. That's okay. We got a 1 here. We got a 0 here. So we could do this. Let's make that into a 1. I'll show you real quick. Time's running out, so I don't have time to let you think about it. You could divide by what? A negative 3. I want this to be a 1. Okay? I want this to be a positive 1. So I could divide by negative 3 or multiply by negative 1/3. That's what I'm going to do. Negative 1/3. Or it's the same thing as dividing by a negative 3. So divide this by a negative 3 or multiply it by a negative 1/3. All right? So let's do it. We'll just put it right over here. So what do? What's negative 1/3 times 0? 0 plus 1 is, the bottom stays the same. Okay? I'm sorry. We're not adding it to the other one. All we're doing is just multiplying by negative 1/3. Sorry about that. Let's get rid of this. All right. So what's negative 1/3 times 0? It's 0. What's negative 1/3 times negative 3? It's positive 1. There's our 1. And then what's this? 9 times negative 1/3, or 9 divided by negative 3? Negative 3. So that's all I did. I just multiplied it and added to the top or anything else because I just wanted to change that to a 1. And then the top's going to stay the same. Well, I got a 1, a 0, and a 1. What's the only thing I have to do now? And I'm done. Yeah, let's get rid of this 2 and make it a 0. So how are we going to do that? Well, we're going to take the bottom. Oh, I thought he left. Gio, you got to leave. I saw you getting up. I thought you were leaving. You got to go to the office. Negative 2 times 0, negative 2 times 1, negative 3 times negative 2. Let me finish this off really quick. So watch. This is, let's make this white. Negative 2 times 0 is what? 0 plus 1 is 1, right? So the bottom doesn't change. What's this? Negative 2 times 1 is negative 2 plus 2 is 0. Let's do this. Negative 3 times negative 2 is 6. What's 6 minus 4? That would be a 2. What's your answer? What's x equal to? 2. What's y equal to? Negative 3. You're done. I don't know. Do you like that better or not? Yeah, after you get used to it, it's better. When you first learn it, you're like, man, this looks way too hard. But after you get used to it, it's not so bad. We'll do more of this tomorrow.